I have no idea whether this is going to work or not, but I thought I'd try to play around with GitHub Copilot and see how much I can use it to code for me without actually typing any code or typing minimal amount of code. So what I have with me here is my Visual Studio Code. It's already linked to GitHub Copilot. So I actually signed up for trying the beta version of Copilot, and I'm going to see whether LeetCode problems can be solved using Copilot or not. This is my first time actually recording something regarding coding. So if it's of poor quality, if what I'm saying makes no sense, I'm so sorry. Anyways, first things first is to try out probably the first problem on LeetCode. So the problem is, as you can see, it's a two-sum problem. Given an array of integers nums and an integer target, return the indices of two numbers such that they add up to the target. So what you have is, let's say, look at the example. You have an array, a list of some numbers. You have a target. So you want to find two numbers inside this list which add up to the value 9. And it's always guaranteed that there is exactly one solution and the solution always exists. But there's a catch. Like, for example, you cannot use the number at the same index twice. So whatever you do, you have to return unique indices. So let's see this. For the first example, you have 2, 7, 11, and 15. The target is 9. You know that 2 and 7 add up to 9. So this output should be 0, 1. You could also return 1, 0. The order is irrelevant. It's fine. Then for the second example, you have nums 3 to 4. So you know that 3 and 3 can actually add up to 6, but you're not allowed to use the same index, which is index 0. So that's not going to be allowed. The output is 1, 2, of course. And then you have nums equals to 3, 3. And then you have the target equals to 6. Of course, you can't use 3 at the same index, but you can use 3 at index 0. You can use 3 at index 1, and you get the solution. There are some constraints, as in it shows the total number of numbers, minimum and maximum number of numbers in the list, the range of the numbers, and then the target value. And right now, we're not going to go for anything fancy. We're just going to get basic solutions. I might think about another video later where we come up with more advanced solutions. But let's come up with naive solutions, and let's see if LeetCode can accept our solution or not. So just remember, it's return the indices of numbers that add to target. So we are going to see how Copilot can help us do that. So let's see. Define, oh, sorry. Come on, man, what are you doing? Okay, so define, what should be the name of the function? Return indices of numbers that add to target. Okay. Let's see what this is. It managed to actually figure this out. Come on. Oh ho. What's this? Wait a minute. Did it directly mooch off of LeetCode, someone's LeetCode solution? What's this? Yeah, okay. Ah, see, it made a mistake. You can return, okay. So now, okay, this is the solution. And whoa, what is this? Return, actually, we are going to assume that the solution exists. So we don't need this. Okay, so as you can clearly see that apparently there have been people who have already done this before. Like someone must have written a code for this particular problem on GitHub, and then that code must have been public, and then Copilot was trained on that code, and so that it knows. Now, something very interesting and very important. The name of the function, if you name your function appropriately, more often than not, Copilot might figure out in general what your problem is about. So you can see that you have the function is supposed to return indices of numbers that add to target. And now you see it automatically generated a description of the function, given an array of integers and a target integer, return the indices of the two numbers such that they add up to the target, which is literally more or less the same. Yeah, it is essentially more or less the same description as the problem, which is pretty cool. You can return the answer in any order. It's over here. You may assume that each input would have exactly one solution, and you may not use the same element twice. It's exactly over here. The only difference is this nums and target variable. They're a bit different, but yeah, more or less it's here. I guess that's because it was probably trained on, I think the C++ description was a bit different. Anyways, it doesn't really matter. Anyways, this is a solution that Copilot gives. First of all, let's run it. I'm going to copy the code. I'm going to go here. I'm going to paste it. Indentation. And I'm going to first run the code and see, let me, I have to sign up. Why do I have to sign up? Jeez. Am I signed up? I am signed up. That's good. That's good. I run the code. And see, the solution was accepted. And I'm going to submit to see if the official submission is accepted or not. And 3, 2, 1. We should know soon. We should know soon. We should know soon. There we go. So now here's the thing. The runtime was deemed to be quite high, which means it was one of the slowest solutions. But now, 1 second, let's try to submit it again. I think there was some issue. 1 second. Let's see. And I guess it's going to obviously take a lot of time. Yeah, okay. So I ran it twice because sometimes, while the submission goes on, something happens in the server. Anyways, that's not a big deal. So anyways, this was an inefficient solution, obviously. So now let's go back to the solution and see what's happening over here. So again, the description of my function was return indices of numbers that add to target. And the solution is actually very simple, right? You go over the list of numbers, and then you consider the other numbers, which means except the number that you're currently looking at, you look at the numbers after that. And if the current number and any of the numbers after that number add up to the target, which is over here, then you just return the indices. And that's pretty much the solution. That's the naive solution. Of course, the more optimal solution is something else. But right now, we're not trying to find the optimal solution. We might want to look at it later. So let's try to see what Copilot even does. Let's see if Copilot actually manages to return this solution to us without us actually making this function name, the name of the function or the description very clear. If we, so that we understand how to make Copilot give us the code that we want. Okay, so first of all, let's wipe out this code. So let's see what kind of function name I can give. So if I say return indices that sum to value, and let's see if Copilot can complete. Come on. Okay. And let's see if this is the thing. So what's Copilot trying to say? Given an array of integers, return the indices of two numbers such that they add up to a specific target. You may assume that each input would have exactly solution and you may not use the same element twice. Order of n time and order of n space, apparently. Yes, okay. So the person who wrote the code, or at least Copilot, the code that Copilot is generating is based on someone's code. And this person has already commented on this. Let's see what they have done. They have created a hash table for I in range length of array, if array I is in hash table, then return hash table array I, comma I. Okay. If not, then in hash table, the target value that you want minus array I equals to I. This solution actually might be the more efficient one. Let's see if it actually works. So let's first of all go here. Actually, none is not necessary. Let's get rid of that because we are assuming a solution no matter what. Let's see. We have to change the variable names, but that's fine. We're going to do that. It's not a big deal. Okay, let's just, okay. All right. So first of all, we call this nums. And then this will be target. And then I guess that should be it. Let's try running this solution first. Wow, okay, that worked. And let's see if, yep, see, there we go. So if you used a more appropriate function name, actually, it ends up giving the perfect solution. This doesn't always happen. So the way you name your functions, really influences the kind of output you get. If your function name, so that's why the most important thing is you should start playing with function names. Now let's try. Now that we have already also obtained the optimal solution, and first let's go through the optimal solution, right? So, okay, so the solution is reasonably straightforward, right? First of all, you have this hash table. This hash table contains, takes key as a number and the value is the index. So for example, what it tries to do is, in the hash table, you would want to quickly store the index of the remainder that you're looking for. So let's go through this. For each number in the array, if that number is present in the hash table, then you simply return the index corresponding to that number and the current index. Why that should work? Because if this number is not in the hash table, then the hash table actually stores the target value minus that number and gives that as the index I. So essentially, if I say hash table for the number, then actually it should return the index of the target value minus the current number. And this is very clever and very straightforward. So this is a very simple solution as well. It's supposed to be an easy problem. It just uses a hash table or a dictionary or whatever you want to call it. And it's really quick. There are possibly many alternative solutions that people can use. So really, it's totally up to you. But I think this is one of the fastest solutions that you can get. Now that we have gone through the solution, let's try to go through, how should I say, other alternatives or other ways of naming the functions and so on. Let's see how intuitive Copilot is, right? So let's say return indices. Let's see what it does with this. Let's see what, by the way, this is the Copilot's icon. So it kind of like tells you what it's searching. So what does it do? Return indices, nums target. And what is this doing? It takes index equals to an empty list for I in range length numbers. If numbers are equals to target, then index dot append. Okay, so it just returns the indices of the numbers in a list that have the target value. So you can see that if your function name is incomplete, then you're going to have to rely on other things. So first of all, let's complete this. Sorry, no. Come on. Sorry. Come on. Okay. Okay. I don't know how to do this other autocomplete mechanisms. Okay, sorry. No. We don't need to do that. So this is where, so suppose you don't have a very clever way of naming your function, or you don't like to name your functions with long names or very descriptive names, or if you want to have more functions with more abstract names, you can always rely on the comment section to help you write the code. No, dude, don't do that to me. First of all, this function returns the indices of two numbers that sum to a target value. And let's see what this does. Two numbers in a list. Okay. And let's see if Copilot actually manages to complete this code for me. Oh, let's see what it does. Oh, I think this might have already, this is okay. Initialize the dictionary to show the values and indices. Yes, that's true. For I comma num in enumerate nums. Yes, if target num minus num is in the dictionary, yes, then return the current index as well as the index of target minus num, else dnum equals to, oh, this is like a alternative to the previous solution that we have. All right. We actually don't need to return none. And you can see, do you see how it actually gave comments over here? First it says initialize the dictionary to show values and dictionary. So it gives you annotated code most of the times, and these are very basic fundamental operations. So it gives you very simple annotated code. Iterate through the list, yes, and then it uses an enumerator, of course. If the target value is in the dictionary, return the indices. Yes, that's true. Otherwise, add the value and index to the dictionary. Yes. If the target value is not in the dictionary, return none. But this is not going to be required because we are already sure. We have been told that the number will always exist. That the two indices, that the two numbers that add up to the target will always exist in the list. And now let's see if this solution works or not. Okay, it's pretty much the same solution that we had earlier, just written in a different way. And run code. Let's see if this works. Yes. And then let's see if this is accepted. It does. It seems to be a bit slower than the previous solution, but you know what? They are just pretty much both roughly equivalent to each other. They do essentially more or less the same thing, and we get the solution. So now I hope you are starting to understand like how Copilot works, how Copilot starts generating solutions. So let's see what are the lessons we have learned over here. The lesson number one, lessons, not lessons, lessons. The first lesson is, no, this is not the lesson. Stop auto-completing, man. Stop it. Okay, the first lesson is that name your functions appropriately. If you are descriptive enough, the code generated, or sorry, the generated code will more or less be what you want. Two, if you do not like verbose function names, then rely on comments to generate the code you want. And the third lesson is, the third lesson that we know is it is possible to get alternate solutions by trying different function names or comments. So definitely consider playing around if you want a high quality solution. There we go, it auto completes. So this is it. And that's about it. You know what, I don't know if I'm going to do this like a long term or whatever, but I recently got access to Copilot. I was quite excited and I really wanted to share this. I wanted to make this video. I don't even know why I'm making this video, but I know I just wanted to put this out there. And I'm not a super coder, as you have probably guessed. I'm not a genius coder. I just love to code because it's fun. And Copilot is the one thing that I think I needed back in the day when I struggled with coding. And I know that Copilot it may seem like Copilot is going to make you lazy, but it's not. Copilot is a nice pair programmer. It is a nice way to avoid having to look up on Stack Overflow or something for basic syntax. So I think Copilot is going to be really helpful. And the more we use Copilot, I think the more we'll be able to, let's say, exploit it to finish coding really quickly. So yeah, so this is it for the video. If you like, then if you like what I'm doing, then just like, leave any comments, subscribe. Yes, and if you're going to leave comments like, oh, you're very dumb or your coding skills suck, then it's okay, you can leave that, but I already know that, so don't worry about it. So yeah, my plans, I don't know if I have any long-term plans or not, but I'm just going to try doing various things with Copilot, like try to solve LeetCode problems, probably try to write some deep neural networks with Copilot, see how efficiently I can use Copilot to, let's say, design some neural networks that I want. I want to see if Copilot can be used to teach students some fundamental coding. I don't know if that's a good idea or not, but you know what? It's a brave new world. Copilot is a new thing. So let's see what happens. But yeah, any comments, any requests you have, like you want me to, use Copilot to do something specific, just let me know. And with that, I bid you farewell and maybe see you soon.